In this video, we're going to introduce profiling in RAMP and some of the main concepts involved. So firstly, what is a profile? I went on the internet and searched for examples of profiles to show you. The first example here is an example of a simple profile that's generated along a stream using ArcGIS Desktop. You can see in the background the underlying terrain dataset and this profile following the stream as it heads downhill or downstream. So a very simple use of a profile. This is also a simple profile. It is very similar to the previous one in that it's also following a creek or a stream. And any profile that follows along something is often referred to as a longitudinal profile. So this is a good example of a longitudinal topographic profile. Okay, this one is very similar conceptually, but also it's a little bit more complicated. It's still following a stream or some terrain as it flows downstream, but you can see the graphics are a lot more complicated. But at the end of the day, it's still showing just one single terrain. So this is an example of another little bit more complicated longitudinal profile. Okay, this is a geological section or a geological longitudinal profile. It's following from the top of a mountain down towards, I assume, the coast or a basin somewhere. And it's showing changes in the surface geology along the way. So we have a graben zone, an uplifted zone, and the main mountain itself. So this is also a longitudinal profile, but its purpose is a geological section. Here's another geological profile or geological section. It's also longitudinal, and you can see that this is more complicated now because it shows multiple lines stacked on top of each other to create volumes of different types of material. So this is what we call a stacked longitudinal profile. Longitudinal profiles can also be offset from each other. So here's an example of a series of geological profiles again that are offset at certain distances from each other to give a general impression of the geology in the area. So these are called offset longitudinal profiles. But longitudinal profiles can also have cross profiles. So back to the stream or creek example again, as this is flowing downhill, periodically at certain locations along the stream or profile, cross profiles are taken that are perpendicular to the longitudinal profile. And here's some examples of what they might look like at different places along this stream or river. So this is a picture of the RAMP profile viewer, and we're going to look into this application in a lot more detail later on, but essentially RAMP can generate all of those types of profiles that you previously saw. So simple and stacked longitudinal, offset and cross profiles can all be generated using RAMP with raster datasets as the main inputs to generate the profiles. So RAMP has a workflow for creating and setting up your profile and then finally populating it with values from raster datasets. The first is to generate what's called a seed profile, and then to densify that seed profile in either or the longitudinal and cross or offset directions to create something called a bare profile before you finally append values from raster datasets to that profile definition to create a populated profile. We're going to look at the RAMP documentation to show you what each of these steps means, but we're actually going to demonstrate them by example in the next video. So here we are in the RAMP documentation for profiling workflows, and you can see the workflow steps that we just discussed. Generation of a seed profile, densification to bare profiles, and then finally appending values from raster datasets to create populated profiles. Let's look at each of these steps and use the diagrams to graphically discuss what it means. So the first step is generation of a seed profile. Now, very often when you define a profile, you define a line and you say I've got a start point and an end point. And that is the center line of the profile that I want to generate. The problem with this is that the profile only has a start and an end point, and it doesn't have any other points along the middle of it. So the generation of the seed profile is purely the definition of the start and end points, or indeed it could also be any of the turning points or sort of inflections along a non-straight profile. You can see what this does in terms of the ramp profile data file. So a ramp profile must have, by definition, a distance along it, an offset, and an X and Y. So in this case, the center line is referred to as offset 0. And you'll notice that there are 2 points recorded in this data set. The first starts at distance 0, and the last finishes at distance 9938.96. They're both at offset 0, and these are the coordinates of those locations. So this is a seed profile. It does nothing more than define 2 points or a couple of points along a non-straight line. What we need to do is densify this line. So that's the next step. When I densify a line, I tell it to start at the start position and add points every X, whatever distance, along the profile until you reach the end. So this is the process of densification. And what this does is that now you start off in the file with distance 0, and it ends again with distance 9938.96, but there'll be a whole series of extra points along the way. So this is called densification in the longitudinal direction. And that's now created what we refer to as a bare profile. The profile doesn't have any values added to it. It just has now a series of points to which I can append later on values. Let's look at the next step. So optionally, I might want to create offset lines from my center line, or offset 0. Or I might want to create a series of cross profiles along the way. So this is densification in the cross or offset direction. It allows me to define how many offset lines I would like to have and how many, or to what width I would like to have them. So now, once I've densified in the cross or offset direction, it adds offset lines with a whole series of points at the same distances along as the center line. So finally, I can now append values to my profile. I have a center line and I have 2 offset lines in this particular example. I then tell it to take an input raster, or indeed a series of rasters, and to take the value of that raster at each of these locations and add it as a new value field into the profile. Now I can add as many or append as many raster datasets as I'd like to my profile. And this is an example here where I've added 3 different rasters to my profile. So now my profile has 3 different value fields. So that was a quick introduction to some of the main concepts in profiling using RAMP. In the next video, we're going to look at actually doing this by example, because it will become more obvious to you what's actually happening and how you do these things. So thanks for watching, and I hope this has been useful.